Start with a bit of old school technology today. This is a record, and it's designed to be played on a turntable. And when I move the needle to the side, this record rotates, and it rotates once every 2 seconds approximately. This is an example of motion we call rotational motion. Every point on the record is moving in a circle, but different points on the record are moving at different speeds, and the record as a whole turns as a unit. It's an example of what we call a rigid body. So this record is doing rotational motion. Now the point of this is this. I put a needle in the groove, and then it plays music. And what happens is this. The needle follows a groove, and I have a vibration recorded in the groove. The record's going around about every 2 seconds. At the outside of the record, the needle is going in a big circle, but by the time it gets to the inside, it's going in a smaller circle. It's going in a smaller circle. Okay, now we're going to bring out a separate player. And this player rides on the record. And when I turn it on, what it'll do is there's a needle which rides in the groove, but the record doesn't turn. The little bus goes in a circle. And let's watch that go. Oh yeah, there we go. And so this little van rides around in the groove on the record and plays the music. And we can see this is going around the record about as many times as the record would go around. Because if I turn on the turntable, it approximately stands still. But we'll go ahead and slow the turntable down. Let it resume its playing. And now we have a question for you. As this little van plays the music, it's going from the outside of the record to the inside. Its speed has to change. How does the speed have to change? We'll give you some choices. And in fact, let's think about this. As it's working its way to the inside of the record, it goes around circles that are smaller. So it's going around smaller and smaller circles, but it's still taking the same amount of time. It's still taking approximately 2 seconds to go around the record every time. Smaller circle, same amount of time. We have a velocity formula to explain that it is in fact going to need to go slower as it works its way to the center of the disk. And that's something we need to think about carefully when we do this type of motion. So here we have a couple of little stuffed animals I put on the turntable. And if I let the turntable go around, the one on the outside is going in a bigger circle. The one on the inside is going in a smaller circle. They each go around the circle once every 2 seconds, but the one on the inside is going in a small circle, the one on the outside is going in a big circle. The one on the inside is going slow, the one on the outside is going fast. And we need to have some way to describe the fact that they each make one circle every 2 seconds, but the one on the outside goes faster. And we need to introduce another kind of velocity, and the kind of velocity we'll introduce is so-called angular velocity. So let's think about this. As the hamsters go one time around the circle, the angle that they sweep through goes through 2 pi. We use radians in this chapter. So they go through an angle of 2 pi, and they do it in a time of approximately 2 seconds. And so their angular velocity is approximately 2 pi radians divided by 2 seconds, or about pi radians every second. Pi radians is 1/2 a circle, so it does 1/2 a circle every second. And that's an angular velocity because it's the number of radians. It's the amount of angle that's swept out per second. So they both go through an angle of 2 pi every 2 seconds, and so they have the same angular velocity. But we know this one on the outside is moving farther than the one on the inside, and so in fact has to be moving at a higher speed. In Chapter 7, you're going to see relationships that connect the linear velocity and the angular velocity. And that's one of the important points that we'll talk about in this chapter. So in Chapter 7, instead of having position, we have angle. Instead of having velocity, we have angular velocity. And of course, we better have angular acceleration as well.